Problem 2 tells us that for some particular quantity, the demand function is right here. So it says the quantity demanded depends on the price this way. And in part A, we're supposed to find epsilon, the elasticity of demand, when the price is 8. So we have a formula for elasticity of demand. It is epsilon equals negative P over Q times dQ dP. So to compute this, look what we need here. We need P, which we have, that's 8. We need Q. Now we don't have Q directly, but we do have the function relating P and Q. So if we know P, we can get Q. Then we also need dQ dP, which is just the derivative of this function with respect to P. So let's start here. Let's get Q when P is 8. So I'm going to come back up here and put 8 in here. So we are going to get that Q is equal to 4,000 over the cube root of 8 to the 5th. But I'm going to write that like this. This will be 4,000 over the cube root of 8, all that to the 5th. You remember from your algebra course that you can take an exponent inside or outside. If I'm dealing with numbers, it's better to take it outside, I think, because it's easier to compute with. This will give us 4,000 divided by, now, the cube root of 8 is 2, and 2 to the 5th is 32. So I get 4,000 over 32, which just happens to come out to 125. All right, so now I've got P, I've got Q, here's P, here's Q. Now we need to get dQ dP. I'm just going to differentiate this function. Okay, so now we need to get this derivative. We need to get dQ dP. So here's our Q. Our Q is 4,000 over cube root of P to the 5th, but our rules of exponents don't really have radicals in them, so let's just convert this to 4,000 P to the 5/3. Remember this index, little number in the corner, comes down as the denominator. And because the numerator is a constant, I'm just going to bring this up and write this as 4,000 P to the negative 5/3. Now, let's get dQ dP is 4,000 is going to come along times, bring that negative 5/3 down. P, decrease it by 1. Negative 5/3 minus 1. Negative 5/3 minus 3/3 is negative 8/3. And I'm going to rewrite that with a positive exponent, but I'm going to do this also. 4,000 times negative 5, negative 20,000, over, now I got the 3 down here already, right? The 3 is in the denominator already. Now drop this down and write it as P to the positive 8/3, and then I'm going to write this like this. dQ dP is this fraction, negative 20,000, 3, and now I'm going to convert this 8/3 back to radicals. This 3 down here will become the index, so it'll be the cube root, and I'll do this, the cube root of P to the 8th. And I want to evaluate this at P equals 8. So let's see where we are now. This will give us negative 20,000 over 3 times, now, here's where we are. What's the cube root of 8? Okay, I'll go ahead and fill it in here. It's going to be the cube root of 8 all to the 8th. So this will be negative 20,000, 3 times, no, cube root of 8 is 2, 2 to the 8th, times 2 to the 8th. All right, so now we're going to get this. Epsilon, the elasticity of command, is negative P, which is 8, over Q, which we found to be 125, times this number here, negative 20,000 over 3 times 2 to the 8th. Now this is a calculator problem, the way I saw it, or you could start canceling some things here. but I'm just going to use my calculator. When I did using my calculator, I got this. I got, what did I get here? The whole thing came out to be 1.666, and it kept going, so that's just that is just 1.67, or convert it to a fraction, I got 5/3. So I'm going to claim here that epsilon, the elasticity of command, is 5/3. And then for part B, way down here in the corner, here's what we know, that if the elasticity is greater than 1, right, so what we have is elasticity is greater than 1, so this is said to be elastic. So demand is elastic. And what that means is that the revenue will fall as the price increases, and it will rise as the price decreases.